Welcome to lesson 2.1. In this lesson, we're going to talk about complex numbers, specifically imaginary numbers, and how to do operations with them and how they're useful when we're solving quadratic equations. Let's take a look at the objectives. First, we're going to add and subtract complex numbers, then we're going to multiply them, we're going to divide, then we're going to perform operations with square roots of negative numbers, and then solve quadratic equations. First thing we're going to talk about is the imaginary unit I. It is defined as the square root of -1, which means I squared is then equal to -1. Instead of all numbers in the form a plus bi are complex numbers, where a and b are real numbers and I is the imaginary unit. Note how the form there is the real part comes before the imaginary part. That's going to be considered the standard form for that. There you go. All right, so if we evaluate these, we just talked about how I squared is equal to -1. If you think about it, then I cubed, you can rewrite as I squared times I, right? Well, if I squared is -1, then it's really like -1 times I, which is just negative I to the fourth. Would you agree? You can consider that just I squared times I squared, which means it's -1 times 1, which is 1. Um, I to the fifth, would you agree, is like I to the fourth times I. And if I to the fourth we just discovered is equal to 1 times I is just I. Okay, I to the sixth, you could argue is just I squared times I to the fourth, right? If I squared is -1 and I to the fourth is equal to 1, then -1 times 1 is -1. I to the seventh, you could say is I cubed times I to the fourth, where I cubed is -I, and I to the fourth is 1. So -I times 1 is just -I. Notice the pattern here. It goes -1, -I, 1, I, then back to -1, -I. What's going to happen here? I to the eighth is I to the fourth times I to the fourth. Well, I to the fourth is just 1, so 1 times 1 is just 1. Notice how the pattern keeps holding. So then I to the ninth is just going to be equal to I. You can break it down the same way we have, but that's the pattern. I to the 10th is going to be then -1. That pattern will just keep going and going and going. So I raised to any exponent is going to be one of four things. So they're going to be I, -1, -I, or +1. It's got to be one of those four. And it's just going to cycle through. Again, we talked about the form of a complex number being a plus bi. Um, when we do operations, adding, subtracting, multiplying, you're going to treat the I like it's a variable just like x. So when we add these two together, we're just essentially combining like terms. So 5 plus 3 is 8. -2i plus 3i is I. That's it. And again, leave it in that form where the real number comes first, the imaginary number comes second. Here where I'm subtracting, what I would suggest is to distribute the negative sign first and then collect like terms. So 2 plus 6i minus 12 plus I. And again, now you're just collecting the real part, collecting the imaginary part. And that'll be your answer. So 2 plus negative 12 is negative 10. 6i plus I is 7i. Okay. For multiplying, again, you're going to simplify these expressions the same way you would if the I was just regular x. However, if you end up with I squared, we will be simplifying it because we know that I squared has been defined as negative 1. So let's distribute here. So 4i times 3 is 12i. 4i times negative 5i is negative 20i squared, right? But we're not going to leave I squared because remember, one. We're going to swap that out. So you've got 12i minus 20. Negative 20 times negative 1 is just positive 20. And remember, the standard form is that the real number comes first. So 20 plus 12i. Your final answer there. All right, for part C, we're gonna FOIL. And then again, at the end, if we have I squared, which we will swap out that for negative 1 and then simplify. But first things first, we're going to FOIL. 7 times negative 2 is negative 4. 7 times negative 5i is negative 35i. Negative 3i times negative 2 is plus 6i. Negative 3i times negative 5i is plus 15 squared. So that negative 15i squared, well, the I squared will turn into negative 1. So that'll actually be, I'm sorry, positive 15i squared will turn into negative 15. Negative 15 plus negative 14 is negative 29. Negative 35i plus 6i, then minus 29i. Okay, I'm going to leave you C and D to try on your own. If you try them and you want to, that's a great thing to jump in the breakout room. If while you're working on the notes, you want to just confirm that they're right, jump in the breakout room, we can talk about it. Or send me an email if it's after class. Now we're going to talk about a conjugate. For the complex number a plus bi, so any standard complex number, its conjugate is a minus bi, meaning the a and the bi are the same. What's different is the sign in between them. Those pairs of numbers would be considered conjugate. The usefulness of conjugates in this context is when I multiply them together, you get a real number. So if I multiply, well, let's work it out. A plus bi times a minus bi. We would FOIL that together. Those two middle terms, abi, you get negative and positive when you add them together, they cancel themselves out. And that b squared is multiplied by I squared. Well, I squared is negative 1, as we've defined. So you're going to end up with a squared plus b squared. The usefulness of multiplying a complex number with its conjugate is to turn it into a real number in the setting of a fraction, because you cannot have an imaginary number in the denominator of a fraction to consider it simplified. So we will use multiplying by a conjugate to rectify that. So in order to simplify the fraction in part A, we are going to multiply numerator and denominator by the conjugate of the denominator, which is just the same terms with an opposite sign. When I FOIL these together now, So 7 times 2 is 14. 7 times 5i is 35i. 4i times 2 plus 8i. Then 4i times 5i is plus 20i squared. We'll simplify that in a moment. For the denominator here, 2 times 2 is 4. 2 times 5i is plus 10. Negative 5i times 2 is negative 10. Then negative 5i times 5i, negative 25i. Up here in the numerator again, this part here will turn into negative 20. We'll combine that with the 14 to get negative 6. 35i plus 8i is 43i. In the denominator, those middle terms will cancel out. So eventually, when you try the next one, you don't even need to, when you FOIL it out, you don't need to, those middle terms are going to cancel out. That's the point of multiplying by the conjugate. I'm only writing it there for note-taking purposes. However, those middle terms will always cancel out. And then negative 25i squared, that's going to turn into plus 25. So then 25 plus 4 is 29. Again, the point of multiplying by the conjugate is so you end up with a real number in the denominator. Okay, I'm going to leave you part B to work on your own, try it on your own, and again, reach out if you want to ask about it. Again, you'll end up doing practice with it, with the practice anyway. Right, for any positive real number b, the principal square root of the negative number negative b is defined by the square root of negative b is equal to I root b. So operations with square roots of negative numbers. First thing I would do is simplify each radical separately. So you end up with 5i. Right, square root of 25 is 5. Square root of the negative makes it I. Square root of negative 4 is 2i. You multiply them together, you get 10i squared, which ends up being negative 10. These are two imaginary numbers to begin with. All right. But in the context of using imaginary numbers and you were multiplying them together, you would end up with negative 10. All right, so again, I would simplify both radicals first for part A. Square root of negative 18. Well, I can break 18 into 9 and 2. So the square root of 3, sorry, square root of 9 is 3. And that negative is going to come out. So you're going to have 3i root 2. And then minus square root of negative 8. Well, I can break 8 into 4 and 2. Square root of 4 is 2. So that'd be 2i. And you're left with square root of 2. You treat, in this operation, you treat I like you would x for any variable. 3i minus 2i is just I, 1i. So I'm just going to write I. And then square root of 2. For part B, I'm first going to simplify the radical there. So that's going to end up being I root 5. Remember, when you square a binomial, it's like you're foiling. Negative 1 times negative 1 is 1. Negative 1 times I root 5 is negative I root 5. I root 5 times negative 1 is negative I root 5. And then I root 5 times I root 5 is going to be I squared. Root 5 times root 5 is 5. I squared is -1. -1 times 5 is -5. So that part will turn into -5. That will combine with the 1 and get -4. Negative I root 5 minus I root 5 is going to be -2 I root 5. Okay. Part C, you have -25 plus square root of -50. I'm going to simplify square root of -50. 50 can break into 25 and 2. Square root of 25 is 5. The fact that you have a negative there means it's going to be 5I root 2. And all that's divided by 15. We can simplify this fraction further because I can divide out of -25, 5I root 2, and 15 you can divide a 5 away. So it's just like simplifying a regular fraction. You end up with -5 plus I root 2 over 3. I'm going to leave D, E, and F for you to try on your own. All right, so a quadratic equation may be expressed in the general form, ax squared plus bx plus c, and then you solve it using the quadratic formula. That should look familiar, especially if you had me last year. The part b squared minus 4ac is considered the discriminant, so just the part of the quadratic formula underneath the square root. Recall, if the discriminant is negative, that's when there's no real solutions. That's what creates an imaginary solution when you have a negative under the square root in the formula. And you'll end up with two negative or imaginary solutions. And they will be conjugates. All right, so the first equation, you need it in standard form to be able to do this. So we're going to add 4 to both sides. So you have 3x squared minus 2x plus 4. First thing I'm going to do is find the discriminant b squared minus 4ac. In this case, b is -2. A is 3, and c is 4. -2 squared is 4. And then 4 times 3 is 12. 12 times 4 is 48, so it's minus 48. So you end up with -44. It's a negative discriminant, meaning we are going to get two imaginary solutions. We'll take a square root of that. We'll simplify the square root because that's part of the formula, if you recall. 44 you can break into 4 and 11. Square root of 4 is 2. That negative will come out as I, so you have 2I root 11. And the rest of the formula is the opposite of b plus or minus what we just found all over 2a. b is still -2, so the opposite of that would be +2. And a is 3, so 2 times a would be 6. Then that can get simplified because you can divide, and you need to divide something out of the 2, the 2i, and the 6. Well, you can divide a 2 out of all of that, so you're going to end up with 1 plus or minus I root 11 all over 3. All right, and then I will leave part B for you to try. So that's it. If you haven't completed the test yet for chapter 1, and when I say completed, I mean you get to submit it twice. Please do that. We'll have Monday and Tuesday to work on the 2.1 practice. Reach out if you have questions, whether it's breakout room or send me an email. I'm here to help. All right, so let me know if you have any questions.